Okay, let's start with systems of equations and introduction to the metric system. Today we're going to determine if an ordered pair is a solution to a system of equations, solve a system by graphing, substitution, and elimination, and then solve applications using systems of equations, and then we will start our metric chapter. So, to give it meaning, Delbert is choosing between two membership options at the local movie society. A director membership has a lower initial cost to the join, but the cost per movie is higher. A producer membership has a higher initial cost to join, but the cost per movie is lower. In this section, what we're going to do is learn how to use these two equations at the same time, simultaneously, to help answer which membership would be a better financial choice. This happens a lot in life where you have to make a decision considering different factors, and when you are doing that, you're actually using systems of equations probably in your head, like without even realizing it. And we're going to actually put it on paper in this chapter. So to begin, you can pause at any time when two or more linear equations are considered simultaneously. That means at the same time. The equations are called a system of linear equations. A solution is an ordered pair, or maybe more than one ordered pairs, that satisfy all equations at the same time. So all of the equations, if we have an ordered pair, an x and a y value, that make all of them true at the same time, that's our solution. Now, just like before, when we find a solution, we can have one solution, we could have no solutions, or we could have infinite solutions. So let's take a look at some. Determine which of the ordered pairs is a solution to this system. Y equals 1/2 x minus 4, and 3x plus 5y equals -9. Starting with 0, -4. Remember, it's x comma y. So we're plugging it in, and we're seeing, does it make both of them true at the same time? If y is -4, when x is 0, is it true? This becomes 0, -4 equals -4, looks good. Now the other one also has to be true for it to be a solution. 3 times 0 plus 5 times -4 equals -9. -20 equals -9. Not true. So this is a big fat no, not a solution. Next, 12, -9. So x comma y, so we've got -9 equals 1/2 times 12 minus 4. -9 equals 6 minus 4. -9 equals 2. Okay, so right away, it's a no. Last one, 2 comma -3. -3 equals 1/2 times 2 minus 4. So we have -3 equals 1 minus 4. -3 equals -3. That looks good. 3 times 2 plus 5 times -3 equals -9. 6 minus 15 equals -9. -9 equals -9. That looks good. This one is a solution. Okay, on this page you can pause it, write some things down that you want to keep with you. These are different solution options that we might see. So in the first case, when it's consistent, that means we found a solution, one solution. We can see it represented by the point of intersection, where each of our lines have intersected at the point. That point is our solution. That's the x and y value that we have found. Some of the characteristics are that the lines have different slopes. That's what causes them to intersect. The second one is called inconsistent. That means they do not intersect, they are parallel, that is when we have no solution because there's no point where they intersect. This is where they'll have the same slope but a different y-intercept. Then the last option is if they end up being the same line. That means we have a dependent system, both lines are the same, they have infinite solutions because the whole thing is the solution, they have the same slope, same y-intercept. Okay, here's the procedure to solve by graphing. So we determine 3 points that satisfy both equations, plot the points, and then graph both equations, and then the coordinates of the point or points where they intersect are the solution. So you're basically making a visual and deciding what type of solution it has based on what you see on the graph. Okay, let's find the solution by graphing. Here we have x plus y equals 4 and 2x minus y equal -1. Start with a graph. I'm going to graph the first one in blue. X plus y equals -4. Now we already went through 3 different ways that you can graph a line in our last class. If you don't remember, please review it. You can either plot 3 points, connect the dots, make a line. You can graph the intercepts, plot those, and then make a line. Or you can find the slope, the y-intercept, and graph it that way. It doesn't matter which one you choose the one you like the best. What I'm going to do is just make a table of x and y values. So if I plug in -1, 0, 1, what will we get? -1 plus y equals 4. So we'll add 1 to both sides. Y equals 5. That gives us -1, 5. Zero plus y equals 4. That will give us y equals 4, 0, 4. 1 plus y equals 4, y equals 3. Okay, we have 3 points. We can make our line. I feel like there's a line on here somewhere. Something like that. Not to scale. I never do anything to scale. Okay, next one, x and y. Oh, that's not what I want. -1, 0, 1. Let's see what we get. Okay, 2 times -1 minus y equals -1. We have -2 minus y equals -1. This will give us y equals 1. So we have a point -1, 1. Next, 2 times 0 minus y equals -1. That tells us that's a 0. Y equals 1. Zero, 1. Okay, hold on. +2. Negative. So This guy's actually below the axes. This one's above the axes. Okay. Two minus y equals -1. 3. This gives us 1, 3. Oh, I keep making... Don't make little tiny errors, and if you do, change them, adjust. Oh, that's nice. Okay, so now we have our two lines here representing each color, and we can see we have one solution, and our solution is at the point 1, 3. So it's a really nice visual. We can see it right away. Here's a pretty version on a graphing calculator. Now, many of you might say, Miss, can I use Desmos to graph my lines? And the short answer is no, don't do it. You need to be able to graph proficiently on paper with your hand and your brain. The long answer is yes. After you graph it, check it on Desmos. The calculator is a great tool to use if you use it right. If the calculator does all of your graphing and then I give you a quiz where you're not allowed to use a calculator and you don't know how to graph, then your grade's going to drop. You already know. So make sure you can graph, because I already know Desmos can graph. All right, next we have the substitution method. This is the procedure that we'll be using. So solve one of the equations for a variable, plug it into the other equation, solve it, and then take that number and plug it back in. So that way we have the x value and the y value. Here we're going to do it. Same problem, but now instead of using graphing, we're going to use substitution, and we should get the same answer. So what I'm going to do is I'm going to solve for one variable. I'll start with the first equation, and I'll just move the y over. That way I have x equals 4 minus y. Now what I can do is plug that in to the x. So 2x is 4 minus y. Minus y equals -1. Distribute. 8 minus 2y minus y equals -1. Combine like terms. 8 minus 3y equals -1. And then we'll have 9 equals 3y. We divide, so y will equal 3. Beautiful. Now we'll take that and plug it back in to what we had. That way we know what x is and y. So we'll do x equals 4 minus, we found out y is 3. 4 minus 3 is -1. So we have -1, 3. No. Positive. 4 minus 3 is a positive number. That's right. You're right. I'm wrong. Okay. Found the solution by substituting it in. Got the same answer, so we're doing okay so far. You're probably doing better than me. All right. Here we have x plus y equals 3 and 2x plus 2y equals -4. Again, substitution. X plus y equal 3. I will move the y over. You don't always have to solve for x. I'm just picking one at random. Usually you want to solve for the easiest one. 3 minus y. Okay, we have x. We can plug it in. 2 times x is 3 minus y. Write the rest. Nothing else changed. Distribute. 6 minus 2y plus 2y equals -4. Combine like terms. 2y minus 2y, 0. So now we have 6 equal -4. We know that's not true. In this world that we know, 6 is not equal to -4. So we will have no solution. Okay? You don't have to go further when you find a discrepancy like this. If we graph those two lines, here is a beautiful picture. We can see they are parallel, they will never intersect, and that's why we have no solution. So if you get to a point where you're like, I think the answer is no solution, graph them, see what it looks like. If they actually do intersect, go and find the answer. Use your algebra. Okay? If you see that they're parallel, then you could give yourself a thumbs up and a cookie and say, great job, you did it, you found no solution, and you were right. Next, y equals -2x plus 3, and 2y equals 6 minus 4x. This one's really nice because look, it's already solved for y. We don't have to solve for a variable. They already gave it to us. So let's plug it in right there. 2y is -2x plus 3. Nothing else changed. Distribute. Okay, now we have the same thing happening on both sides. 6 minus 4x is happening on both sides of our equation. So, that is true, but that means that we have the same line. So this is infinite solutions. Okay, double check it. Graph them, and then you'll see that they make the same line. When that happens, then you know it is infinite solutions. The whole line is the answer. It looks like there's just one, but notice we've graphed both of them and they just happen to be on the same line. That's how you know. All right, the last procedure we have is to solve it by using what the book is calling the addition method. We probably have heard this by calling it the elimination method. So what we will do is rewrite the equations so that way the variables are on one side of the equal and the constants are on the other. Sometimes you'll multiply by a constant, but really what you want to do is add them together so that way one of the variables gets eliminated. Once you eliminate one of the variables, then you have solved for one. Then you go back and plug it back in and find the other. Let me show you what I mean. It's always better when you have a concrete example. So 4x plus y equals 13, 2x minus y equals 5. What we are doing is we want to eliminate one of them. So I see right away when I see these types of problems, I'm looking for where one of my variables has the same coefficient but different sign. I have positive 1y and negative 1y. That's beautiful for me because now I can just add them straight away and the y's will eliminate each other. So 4x plus 2x is 6x, and 13 plus 5 is 18. Divided by 6, x equals 3. Okay, I'm not done because I need to still know what y is, so I'm just going to plug it into one of them. 2 times 3 minus y equals 5. 6 minus y equals 5. That means y equals 1. Now I have my x and y, so x 3, y 1. Okay, 4x minus y equals 2, 3x plus 2y equals 7. This is the case where we don't see the x's have 4 and 3. The y's have 1 and 2. So in this case, we're going to have to multiply one of the equations to get that nice elimination happening. Here, the most simple move that I can see right away is I have positive 2 here, so I can easily multiply by 2 on the first equation and get a negative 2. Then they'll be opposites of each other. So that's what I'm going to do. I'm going to take this one and multiply by 2. So that's going to give me 8x minus 2y equals 4. You distribute it all the way across. This one stays the same. We did not do a single thing to this one. Now, I have plus 2 and minus 2, so I can add these equations, and those will eliminate. 8 plus 3 and 7 plus 4. I divide, and I get x equals 1. Okay, again, we're still not done. We got to plug it back in and find out what y is. So we'll do, I guess we can use the other one this time. 3 times 1 plus 2y equals 7. It really doesn't matter. You can plug it into any one. I don't want to show you the same process every time. I'm going to mix it up just a little bit so that way if you experience something different, at least you've seen it at one time before. Move the 3. 7 minus 3 is 4. Divide by 2. Y equal 2. So our solution, x1, y2. Okay, let's do this one. 3x minus 4y equals 8. 2x plus 3y equals 9. So I have x's 3 and 2, y's 4 and 3. I cannot multiply by anything in one of them to make the opposite of the other. So in this case, we're going to have to multiply both of them by something. Let's just stick to the x values. 3 and 2, I know that if I multiply this one by 2, I'll get 6. And if I multiply this one by negative 3, I'll have negative 6. And that will make them so I can eliminate. So if I multiply the top by 2, 3 times 2 is 6. 2 times negative 4 is negative 8. And 8 times 2 is 16. If I multiply the bottom by negative 3, I have negative 6. 3 and negative 3 is negative 9. And 9 times negative 3, 9, 18, 27, negative 27. Okay, we see that 6 minus 6, so we eliminate. Negative 8, negative 9, negative 17. And then 27 and 16, we take the difference, we'll have 11. And it's a negative. Divide. Don't be afraid. Fractions are fine. Negative divided by negative, 11 over 17. Okay, and just like before, we're still not done. So we will plug in our y value. We will get our x value. Choose whichever one you want. 3x minus 4y, 11 over 17, equals 8. Now we multiply 4 times 11 over 17, 44 over 17 equals 8. And then add it. And then 3x equals, let's see, 136 plus 44, 180 over 17 divide by 3. X equals 60 over 17. Let me double check myself. Yeah, I'm gonna leave it like that. Okay, so now X 60 over 17, Y 11 over 17. And what I don't want you to do is get really freaked out just because you're using fractions. In some cases, they won't be whole numbers. You might have decimals, you might have fractions, and that's okay because in real life, almost nothing deals with completely whole numbers. Okay, modeling. Now we're going to do an application. At a collectibles show, Richard could sell model trains for $35. The cost for making the trains are a fixed cost of $200 and the production is $15 a piece. Write an equation that represents the revenue and then an equation that represents the cost. So, first let's talk about what these words mean. Revenue, that's money that he makes. Cost, money that he spent to make these things. An equation representing his revenue is going to take us, we're going to have to multiply what he's making times how many things he made, right? And so we'll look at, he can sell for $35. That's how much he could make off of just one. So then we'll look at how many did he make. I'm going to represent the trains, however many he makes, with X. So his revenue, I'll make R of X. And I'm going to say his revenue will be $35 times however many he makes. His cost will represent with C. And the cost is going to be not only the fixed cost of $200, right? Maybe he had to $200 get the startup, whatever you need to start making trains. Maybe it's the tools and a table and gloves, whatever it is. $200 just straight off the bat. And then $15 a piece. So for the specific metal it takes to make these trains, or plastic, or paint, or screws, $15 every time he makes a train. And that would be the X, right? However many made. And now we have an equation for these things. So how many model trains must he sell to break even? Well, in order to break even, what does that mean? That means that however much money he made is the exact same as how much it cost to make them. Like, he didn't make any profit, he just broke even. So we'll set those two equal to each other. And in this case, we'll solve for X, get your X's on both sides. And then isolate. So we have X equals 10. What does this mean? This means he must sell 10 trains to break even. Okay, write an equation for profit. Profit means that the revenue has surpassed the cost. However much revenue he made, if he takes out what it costs to make them, there's something left over. So we're going to write that down. Profit, I'm going to represent with P, is whatever revenue he made, subtract off the cost. Whatever's left is his profit. So we said revenue was 35x. We'll subtract off the profit, we'll subtract off the cost, which was 200 plus 15x. We should be left with the profit. So is the profit that he makes, we'll have 35x minus 200 minus 15. So we'll have minus 200. We have our profit. Use it to determine his profit if he sells 15. Now we're going to just plug in 15. He made 15 trains. 20 times 15 minus 200. Okay, so we've got 300 minus 200, 100. He made $100. Okay, how many model trains must he sell to make a profit of $600? So now we're going to use that. Our profit, we want 600. Okay, what is the profit? That was 20x minus 200. So now we could just use this part and solve for how many does it take to get to that 600. What is our x? So we'll add we have 800 divide by 20 80 divided by 2 is 40, and it would take 40 trains to make a profit of $600. Okay, that's our last example for chapter 6. We're going to introduce chapter 7. So, moving into metric. Recall from your sciences, most measurements are in metric. So, chemistry, maybe you worked with liters. Physics, maybe you worked with mass. In this section, we're going to go through some benefits of using metric. So, here's the metric. Two systems of weights and measures that exist side by side in the U.S. are U.S. customary and then metric. Here's a picture. The top is a meter. The bottom is a yard. You can see there's a slight difference, but these are the two different measurements that we use here in the U.S. The meter, represented with an M, commonly used to measure length. Just to give you an idea, 1 meter is a little more than a yard. A door is about 2 meters. Kilogram, represented by kg, used to measure mass. So 1 kilogram is about 2.2 pounds. To give you an idea, a newborn baby may be about 3 kilograms. The gram, represented by G, is used to measure small amounts. So like a nickel has a mass of about 5 grams. Then the liter, the script L, uses are commonly used to measure volume. 1 liter is a little bit more than a quart. So a gas tank on a car may hold 50 liters. Then we have temperature. Metric uses degrees Celsius. Ideas about Celsius: the freezing point of water is 0, boiling point is 100, and everything else falls in between. So the temperature on a warm day might be 30 degrees Celsius. And here's some more, just to give you a better idea. Comfortable room temperature might be 73 degrees Fahrenheit. That equates to 23 degrees Celsius. Our body temperature is 98.6. That's about 37 degrees Celsius. So just to give you an idea. Okay, here is my favorite diagram for converting using metric. In the middle, we have our unit, meter, liter, gram, whatever it is we're measuring. If we want to use deci, centi, or milli, we will multiply by 10 to move it over that way. If we are going to deca, hecto, kilo, we would divide by 10 to go that way. So basically, to convert in metric, you're just moving the decimal around. Here's another visual for you. So all of these kilometer, hectometer, decameter, meter, decimeter, centimeter, and millimeter have all been turned into how many meters do these equivalent, or are they equivalent to? I think I'm making up words now. So all of these are good resources for you if you are reviewing or trying to master using metric. Okay, so let's look at this one. Converting from basic metric units. If we want to convert, let me pull our diagram down. To here. All right, so from meters to kilometers, we're starting at our unit and we're going to kilometers. So we go 1, 2, 3 that way. So it goes from 457.3. We move 1, 2, 3. Fill in with 0. It'll become 0.04573 kilometers. And that's it. That's converting. So let's do another. Grams to centigrams. So we're starting in our unit, 1, 2. Okay, so we'll go this way twice. 1,400 centigrams. .53 liters to milliliters. Okay, so we're gonna go 1, 2, 3. 1, 2, 3. 530 mils. And then liters to kiloliters. 1, 2, 3. So decimals at the end. If you don't see it, the decimal's at the end. 1, 2, 3. 2.45 kiloliters. Okay, converting metric units. Let's see if it will. Here we go. I'll just keep that guy with us. 704 millimeters to hectometers. Millimeters are way down here at the end. 1. 1, 2, 3, 4, 5. Remember, decimals at the end. 1, 2, 3, 4, 5. So 0. We add 2 zeros. 704 hectometers. And then we have the decameters into decimeters. 1, 2. 1, 2. Okay, 634 decimeters. Oh. There you go. All right, the signs in the photo from Beijing, China show the distance to this inner street. It's 500 meters. The speed limit is 80 kilometers per hour. Determine the distance in kilometers. So we have all of our resources here. Okay. 500 meters, and the speed limit is 80 kilometers. Determine the distance. So right now, we have it in meters. We want it in kilometers. Meters to kilometers. 1, 2, 3. So 500 meters becomes 1, 2, 3, 0.5 kilometers. Determine the speed in centimeters per hour. So right now we have kilometers per hour. We want it in centimeters. Kilometers to centimeters. 1, 2, 3, 4, 5. So we'll have 1, 2, 3, 4, 5. We're adding 5 zeros. 1, 2, 3, 4, 5 centimeters. So it's 8 million centimeters per hour. Lots of centimeters. But if you think about it, kilometers really far, centimeters really small. Makes sense. Okay, range from smallest to largest. We have 2.3 meters, 3,421 millimeters, and then 104 centimeters. Let's put them all into one unit. Doesn't matter which one. If I just start here, we have 2.3 meters. And then we'll do this one. So it's in millimeters to meters. 1, 2, 3. 1, 2, 3. So we have 3.421 meters. Now let's do this one. 104 centimeters. And to meters, centimeters to meters. 1, 2. 1, 2. 1.04 meters. Now they're all in the same unit, meters, and we can easily put them in order. So smallest to largest, it says. So we go 1.04 meters, then we'll do 2.3 meters, and then we'll do 3.421 meters. But that's not where we end, because that's not what it gave us. So we have to put them back in. Now that they're in the right order, we got to put them back in the units they were given to us. 104 centimeters, then 2.3 meters, then 3,421 millimeters. There we go. All right, that's it for this section. Do your biblical worldview. Just explain why our journey with Jesus is not always linear. Make sure you're writing 300 words. You're using a quote from the article. You have an in-text citation. After your quote, you should be citing it in text. If you don't know what in-text citation is, ask an English teacher or Google it. APA citation at the end. I've given it to you, so use it. It's the only freebie that you'll ever get in writing a paper. My lab homeworks. We are the Tuesday, Thursday section. So 6.5, 6.6, 6.7, 7.1. Make sure you're studying for your exam. It's about 2 weeks away. So you're doing practice problems in the study plan. You're starting to make your note card. You're getting yourself ready to bring up that exam grade from exam 1. Okay? Everybody should be working hard. Make sure you're using free resources. ACU has free tutoring in the library for Math 105. Don't waste it. Use it. Ask your questions and get your answers. You can always email me, and you can always schedule, office hours as well. So study hard, work hard, and finish strong.